Hello all, let's go ahead and do a quick review on logarithms and exponents. So the first example, we are going to rewrite in exponential form. So it's already shown with a log, so therefore we're just going to take that log away and then start, since the log is on the left-hand side, we're going to go from left to right and we're going to take that base, and this time we're just going to make it a bigger number. Then we're going to go to the opposite side of the equal sign. That's our new exponent, and then back over to the other side of the equal sign. So that is going to look like this. Now, if you wanted to test your work, what you can do is just put it in a calculator and just recognize 625 to the fourth power simply means, if I rewrote it, the fourth root of 625. Go ahead, try it, put it in your calculator, and guess what? You will see that your answer equals 5. So that's how you can test that. Now the next one, if I'm rewriting in log form, well, guess what's missing? The abbreviation log. So that's what we're going to put in front of this 19. So it looks like this, log, and this time the base is now a small number. And then we still do the same thing. We go to the opposite side of the equal sign and then back around. So the big number next to log will be 1 this time, and then it's set equal to 0. And again, if you were to go backwards and write it in exponential form, it will look like this. All right, so what I do want to point out with this, when you see log form and you see a base that's given, even if it's the base 10, you would actually use the abbreviation log. But if you saw something like e to the second power equals 3, and that's just me making something up, then instead of using log when you rewrite it, guess what? You would use natural log. But your base is understood to be e, but you still use the same concept. You go to the opposite side of the equal sign and then back. So 3 is equal to 2. So that's what that would look like if you had a natural log. All right, so example 2, we are trying to evaluate. You may see simplify. It means the same thing. Basically, what is each one of these logs as a number? And what does that mean? If you need to go back to my properties of logs so that you can recognize that this is a property that's shown here, the inverse property that says if my base and my value are exactly the same, I can just cancel it out and bring down what's left over. Well, what's left over? The 4. So 4 comes down. There is a minus sign there, so I'm going to bring the minus sign down. And then the next what I'm evaluating now is log base 5 of 125. Well, what does that mean? That means 5 to the what power is equal to 125. So if it helps you, just put equal x here and then just follow your rules that you know about exponents. Okay, so that's all I'm doing to the side over here. And when I actually figure this out, 5 to the what power? 5 times 5 times another 5. How many 5s do I have? I have 3. So to evaluate this entire log problem, I would have to do the math, simplify, and it is 1. That's it. So example 3, we're asked to expand the logarithms. The first thing you want to do is count how many terms or values do you see in your parentheses. I see 3. So guess what? I am going to have 3 logs when I expand this. So let's take it one step at a time. Starting with the first one, I am going to have a log base 2 because that is what's given. And then of what? Of 8. And then I'm going to go to the next one. And this time I see it has an exponent. So I have to use my power rule. And I also have to understand everything that's above in the numerator, it's going to have a plus sign in front of it. So there is understood to be a plus sign there. And now there's going to be a plus sign here. The power rule tells me to move the exponent out front and then write the log base 2 of what? Of x. That's what the exponent is going with. So now the rule tells us if we're using a quotient power, which we are because we have a fraction, that anything that is shown in your denominator, and by anything I mean this 5, it will have a subtraction sign in front of it. So subtraction sign is shown, and then it's still another log base 2 of what? Of 5. So you will think you're finished, but you're not. When you are expanding, you have to look at each individual log and see whether or not you can simplify it further. You can. You can simplify this. What is that? That is actually 3. So 2 to the what power will give me 8? 3. So this is now 3 plus, and if I go to the next one, I cannot simplify that any further, so I keep that. Go to the next one, I can't simplify that one. So my final answer is actually this. So when you're expanding, pay attention to see whether or not you can further simplify. So for part B, if I am expanding, again, I'm looking at, if it's not in parentheses, then whatever is next to my log, how many of those values do I have? 1, 2, 3. So guess what? I'm going to see log base 4 3 times. So that's what I'm going to write first, log base 4. Now, there's multiple ways to write this. So this really means log base 4, and then in parentheses, it is x, y, z. And whenever you see something next to each other, it means you're multiplying. And all of that is raised to the 1/2 power. The square root simply means 1/2. So if you look at it this way, then it might help you to understand how to expand it. Again, you can write it multiple ways. So one way is 1/2 times log base 4 of each one of the values that you see. So I have x, and then since it's multiplying, I have to change this to a plus sign, log base 4 of y plus another log base 4 of z. And again, you see it's in parentheses, that's telling me this 1/2 is going to be distributed to every last one of those logs. That's one way. Another way you can write it is take your log base 4 of x, and it's understood that there's a 1 in front of that log base, and then write it over 2, plus, and then do the exact same thing for your y and your z. Make sure you understand it means the same thing, okay, of z over 2. And that's just, let me make sure I got all of them. So again, I have 3 logs when I'm expanding it. And that's just 2 ways. You can also put 1/2 in front of each one without the parentheses if you wanted to do it that way. So it means the same thing. Let's go to example 4, which is condensing. Condensing means I do not have it expanded out into 3 different logs or however many logs that are given. Condense means I simply have 1 log, and the log that I am going to use is what's given. So I have log base 3. Now I have to look at my signs. My signs tell me whether or not I'm going to have a fraction. If I have a negative sign, I will have a fraction. If I have a positive sign, that means that's the information that goes in my numerator. So log base 3, and now I'm going to take it one step at a time. So the number that's out front is always your exponent to this value. So this is going to be x to the 4th. Plus means that the next item is going inside, on the numerator. Again, this is still a exponent for y. But when you're condensing, we wouldn't write it as y to the 1/3. We would actually use it the radical form, which is cube root of y. Subtraction, that tells me I am now going to the denominator. This is still my exponent, but my exponent for z. So z squared. So that is my answer when it's in condensed form. Example 5, I am solving equations. Make sure to check for extraneous solutions. Now you see log, the natural log, but it has the same rules as log. So if I see a plus sign here, that tells me I'm going to use my product property. Again, look at my property of logs video if you forgot this. What that means is I'm going to condense this into one log, or natural log in this case, and I am going to multiply my values. So when I do that, that is going to be x minus 8 times x minus 10, set equal to the natural log of 8. So over here, if I combine this, I am going to end up with, and I know some people probably don't remember, but let's use the box method. Or if you wanted to, you can use the distributive method, sorry. So that's going to be x squared, negative 8x, negative 10x, and positive 80. What I did was I multiplied the x times everything on top, and then these were my answers. And then I went to the bottom and did the same thing. So I took the negative 10 multiplied times x, that's where that came from. Then negative 10 times negative 8, that's where that came from. And now at this point, what I want to do is combine like terms if I have any, and I typically do diagonally, typically, it's not 100% like that all the time. So I have x squared, and then I start from my first box and just go left to right. So x squared, and then I can combine that to end up with negative 18x plus 80 is equal to the natural log of 8. At this point, I can factor because I have two natural logs on either side. They can be dropped because that's also a property. So again, make sure you understand that if it's 1 to 1 and it's exactly the same, you can get rid of it, bring down what's left over. So what's left over is the value. And now I'm going to put it in standard form, which means I am going to subtract 8 on both sides. And that's going to leave me with x squared minus 18x plus 72 equals 0. And now the fun part, factoring. So when I factor this, I end up with x times x is the x squared. And again, if you need to, you can go over to the side, and your first box is always your first term, and your last box is always your last term. You are multiplying that coefficient that's in front of x squared, which is understood to be 1, times that 72, and trying to find two factors that will multiply to give you 72, but they will add to give you negative 18. So I understand that that's going to be negative 12 and negative 6. So that's the information that you're putting inside of the box along with the x, because it's replacing the negative 18x. So negative 6x. And now at this point, this is where you want to factor. So I always go to the left first. And when I factor here, I see I can take out x because that's the greatest common factor between the two. Because there is a negative that's near where I'm about to write, I'm going to take out a negative, and then I can take the 6 out as well. And going in the opposite direction, which is going up, vertical, I'm going to do the exact same thing. The greatest common factor between x squared and negative 6x is still x, and then the greatest common factor between negative 12x and 72, and because there's a negative there, it's going to be negative 12. So those are my two factors. So that's what I'm going to use inside, over here to the side, negative 12, negative 6, but it's set equal to 0, which means I have to solve for x. So let's go over here since I'm running out of space here. So x minus 12 equals 0, and x minus 6 is set equal to 0. It's always going to be the opposite sign. Think about it. What minus 12 will equal 0? It's got to be positive 12, right? So x is equal to positive 12. And then over here, what minus 6 will give me 0? It's going to be the opposite sign. X is equal to 6. Well, you can't just assume that is correct for the sake of time, because this is a review. It's going to go on for a long time. I have put this in the calculator to check for my extraneous solutions. All right, so if I put that 6 in, well, I can automatically see it wouldn't work because 6 minus 8 will result in a negative value, and you cannot have a negative value after your log or your natural log. So that's why the calculator told me it's an error. On the opposite side, I saw that I have a natural log of 8. So let me go back to my calculator that I keep losing. So for the natural log of 8, if I put that in the calculator, it told me it should be 2.079, so on and so forth. So now if I take my x equals 12 and I substitute it in for my x, I see that, wow, it does balance. So the only option when I am using this particular problem would be that I can keep the 12, but I cannot keep the positive 6 because it's an extraneous solution. Okay, bear with me, you guys. So solving when it's in the form of an exponent. Now, I'm going to show you two ways. The first way is just rewriting it. So 4 and 8 can both be rewritten as 4 can be 2 to the second power, but I also already have an exponent, x plus 1, so I have to keep track of that. And then 8 can be rewritten as 2 to the third power, and the exponent that's already there is 2x minus 1. So now I see that my bases are exactly the same, so I can just get rid of them. At this point, I have to distribute. That's where you're going to mess up. If you're going to mess up, you forget to distribute. So bring that down as 2x plus 2 is equal to 6x minus 3. And now we're just going to solve for x. So I'm going to subtract 2x on both sides so I can get rid of the x's on the left-hand side. And now I am going to end up with 2 is equal to 4x minus 3. So now I want to get rid of the constant on the right-hand side. So I'm going to add 3 to both sides. And I end up with 5 is equal to 4x. And now I want to solve for x by dividing both sides by 4. And when I do that, I see that x is equal to 5 over 4. And again, I would go back and I would check my answers to make sure they're not extraneous. And I've done this already. So it is 5/4 could work. So that's safe to go ahead and box that. And now let's go over to my other way. So this way is a little bit more tedious, but you need to know how to do it because sometimes you can't rewrite these. So if you can't rewrite it, you need to know your properties. The properties that you would use is your power property, which tells you to move your exponent to the front, write log, and then whatever your value is, in this case is 4, and do the same thing over here. So whatever my power or my exponent is, that's going to go out front. I'm going to write the abbreviation log, and then I'm going to bring down my value. At this point, you would try to get rid of the logs, but guess what? They're not the same, so you can't. So what you would do is you would divide both sides by one of the logs. So I choose to use log base 4. And when I do that, this side goes away because anything divided by itself is simply 1. So I'm going to bring down x plus 1 is equal to, now for the sake of, well, log base 8 and log base 4, in this case, I can use the common base 2, and then I can evaluate it. If I did that, I understand that 2 to the what power will give me 8. Well, that's simply going to turn into 3, so I can get rid of that. And then 2 to the what power will give me 4, 2. So really, log of 8 divided by log of 4 is 3 over 2. So that's helpful to know because now I have to take that information and I have to distribute it to everything that's already here. So I can get rid of the 2's when I am distributing it to the 2x. So that will leave me with 3x. And then negative 1 times 3 is just going to end up being negative 3, and then, of course, over 2. So it's going to be the same thing. You can change this to a decimal if that helps you. It's up to you. So now what I want to do is I want to subtract x on both sides. And I'm going to add 3/2 on both sides. Or again, if you feel comfortable changing it to a decimal, then do that. All right, so on this side, I have 2x is equal to, well, if you understand how fractions work, a 1 is simply whatever this denominator is, you put it, it's a numerator over, it's going to be the same thing. It's just going to be 2 over 2 instead of using 1. So now if I added this, I have 5 over 2 because 2 plus 3 is 5, and then your denominator is already common, it's 2. Now you're going to divide both sides by 2. See, this is where that math comes in handy. Oh my gosh, I don't know how to divide a fraction by a fraction. Sure you do. So this fraction at the bottom is really 2 over 1. So the rule states that when you're dividing a fraction by a fraction, then really what you're doing is multiplying it by the reciprocal. So whatever your denominator is, you just flip it. So instead of 2 over 1, it is now 1 over 2. And this is set equal to x. So now when we multiply, we simply multiply the numerator across and the denominator across. So I am just going to put the the variable on the left-hand side, and 5 times 1 is 5. 2 times 2 is 4. Isn't that what I just said that the answer was? It sure was. Same thing, right? That's just another way of doing it. And again, you will know how to do this because sometimes you will not be able to rewrite that base. So take notes, make sure you understand how to do it. And finally, all right. Change of base formula is simply saying if you needed to break this single logarithm apart, what you want to do is you want to write log on both the numerator and denominator. Think of basement. Basement goes in the bottom. So that's where that goes. Well, you only have one number left. So guess where that goes? Ta-da, you're done. All right, so if it's already in that form and they want you to write it as a single log, then you just write log. Single log means basically condensing. Basement or base is what's going here. You only have one number left. That's going there. That's it. So this is what will be on your assessment. So if you have any questions or concerns, please email me, let me know. But for now, go ahead and click that thumbs up and subscribe. Have a great day.